let's come to the next part. So I have read many of your blogs and they are in my bookmarks. Okay. So, but like there are two blogs which stuck in my mind. So I wanted to discuss over them. One is
Okay.
mathematical programming and the other one is how to build a great network. So
Okay.
can you please elaborate few points for our audience so that they,
Okay.
like, I'll ask them to read the blog because it that is in itself is very complete. But like you being an author of that, can you just please describe few of your favorite points from
Okay, I like it because those two articles are not very highly cited in the TDS, but maybe one of them is actually mathematical programming has been highly cited and it has been got some badge or something from the Kerry Nuggets also.
that? Okay.
How to build a great network is a different kind of totally different thing.
Yeah.
But let's talk about the mathematical programming first. Little bit is that it's extremely simple, right? In somebody in a party or something like that, one of my friends said, oh, this how to calculate the whole blog is about describing a way to calculate like pi, like the number of constant pi, how to do that by throwing some dirt on the dirt board, like you fix a dirt board on a wall and you throw the darts, and then basically that random behavior gives rise to the pi, mathematical programming pi. Now that's fine. It has a very rigorous kind of mathematical or kind of statistical basis for it. So the thing is that I thought that, okay, I'll just write up a program for it, see whether it's working or not. So this is actually about a mindset of a scientist or experimental kind of thing. That's the fundamental thing about it. I mean, you hear about something and you think that I can, code it up and then test it and then write it. I mean, for people to see kind of thing. Now people have put together videos and stuff like that about this particular topic also, how to calculate pi, but I thought that I will write on. So the thing I have to take about, not about the specifics of it, but the point about the experimentation mindset. And so this is a habit, like the mathematical programming is a habit which needs to be inculcated and practiced throughout. If you want to have impact and success as data scientist, or in general, in general, if you want to take part in the new wave of technologies that we are seeing, you have to develop this habit. For example, even if you are not in the programming job, even if your vocation is whatever job you are, is being impacted tremendously by the flow of data, right? So example, like the only way actually to make sense of this streaming data is to somehow develop this habit of mathematically model it and then use it for better prediction or control or something like that. So even if you're a biologist, if you're a financial planner, psychologist, nurse, healthcare provider, I mean, think about it. Basically, in Stanford here in Silicon Valley, or if you hear about Andrew Ng's company, one of the first thing that they came up with, and in the Stanford lab, is also a prediction of mortality rate, which is a tragic topic. But you have to predict how long people will live when they are at the end of their life. And they're in US healthcare because of the rising kind of average age is high and baby boomers coming to advanced age. This is a big deal that basically hospice care and nurse they need to be aware of that. So they need to also interface with this kind of new technologies, and this kind of technologies, healthcare is a big thing. So everywhere it is the data, and if you have some kind of thing which you can yourself just look at a program or interface with them or interact with them, understand how the interfaces and the limitations, then you will feel powerful automatically. So that make that understand, that was my whole point of writing that particular data. The article. And the other one is about the how to.
Sorry to interrupt. Before moving to the other article, I had one question. So as you said, you heard about that particular topic, whatever, that throwing darts and calculating value of pi.
Right.
And then something is stuck in you that, no, I need to try this out. Okay. And you went on and did the programming. Okay. Let's say I'm a person, I'm trying to get into this particular field, but I don't get that excited, or let's say I'm not that. So is this something which can be developed by practice? Because I think you have said that this part also, that this is a habit which needs to be practiced. So I wanted to know, is this a mindset that one can develop, or is this something which is inherent to you? Like, no, it can't be developed.
So this is a good question, and what I said that in general, the mindset about trying something new, something which is rational, like logical, in the sense that a scientific kind of thing which will follow one hypothesis and then result. This thing is very inherent. I mean, it's inherent to me, or it's probably inherent to humankind because otherwise we will not be different from animals, right? I mean,
Yes.
but because we try and fail and then we learn new things. And if someone is not okay, you are saying that you're not excited about mathematical topic, you want to excite about new movies, right? Okay, that's an experiment. You want to see new movies and new genres of movies and something like that. You're still doing an experiment. It's doing a very complex. It's doing the experiment on your mind, right? I mean, that's like a different psychological experiment. You want to gain different experience, or you want to travel to different places. That's also fine. It's about the same thing. It's about the experiment and thing, getting the results. So in my case, it is that one of the reason of doing this thing, I am excited about this kind of thing, is that my job as a semiconductor designer or something like that, that's actually there also I have to do a lot of experiments, but those are expensive. So throughout my life, in my professional career, I have been in a field where it actually takes a lot of educational qualification, research experience, etc., to get into that field and do something. Versus if you think about a data science or mathematical kind of programming, what do you need? You just need one simple laptop and you can experiment with ideas all over the world. People have talked about. So it's so easy. Actually, the barrier of entry is basically so low. You are in a golden, you are in a gold situation to do something about it. So I suggest that, versus some of the other fields like economics and biology, it's difficult to learn something because they take money, that take resource, that take lots of years of experience. Versus this one is actually open to you. So take advantage of it. I think that's the best advice or best kind of push forward I can give to people who want to learn.
Yes, perfect. Yeah. Okay, cool. Yeah, you can move to the next.
And other article we just talked about, we can talk about 1 minute, is that the build network is that, yes, so building network is very important. And I had only less than 500 people 2 years back when I started on LinkedIn, when I started this data science learning, and kind of 2 or 3 years back actually. Okay. And now I have more than 5,000 or something like that. It's because that I express myself. I write articles, I give links and stuff like that. And also a lot of and it does not take you much of your time. So I give you one simple example is that how to build good relation and network is that these days I get a lot of questions from junior data scientists or other people who are trying to, not only junior, who are like in same my situation, like in a different field working, but they want to get into this new field. They want to learn, so they asked me how to start, etc. So initially I was kind of a little bit overwhelmed by this question, so I would not always respond. But now I thought that, okay, I have written like 4 or 5 articles just for on that topic, right? How to start, etc. kind of thing. So I have a ready-made kind of bookmark link kind of thing. All I have to do, like 30 seconds, I have to search that thing on my computer wherever I am in the world, and just kind of copy paste that thing to the LinkedIn thing. As I said, okay, I have written 4 articles, go through it, and then if you have questions later. Most of the time the articles are complete so that they get to learn something from it. So this way I always try to help people. They send me direct message kind of thing. Sometimes I downloaded your GitHub and then it's not working. Some of those questions are kind of sometimes silly, sometimes important questions. So if I feel it is I just try to write at least 1 line response to them. So try to be a little bit helpful. If you set aside say 20-30 minutes of your day and helping and communicating with the people, you will find over the course of 1 year you will build your networks 10x times. And they always help you. I mean, it's like a cumulative effect. It's like a geometric progression. 10 people and they can lead to 100 people, then lead to 1,000 people. So it is starting is difficult. It's slow exponential kind of growth, but then you have a lot of people, and that's how it is important to build good network.
Sure. I just love that point, that be helpful. So most of us think networking as a part from where we can gain something, like, okay, I'll network with this guy and I'll get something in return. But you have defined it in a very proper way that you should be always helpful. Okay, so when you are helping others, you are not like many of, I think it had happened to me many times, it had also happened to you also, that many times I am not very clear about something, but when I'm explaining to someone or something like that, some part of that gets clicked in my mind. Okay, then I relate. Okay, this was like that. So that's a very good way, and I'm very thankful that you are taking some time out to help the beginners into this field. Cool. Okay. So this directs me to the next question. So I'm going to give you a very hypothetical situation. Let's say you're writing a book. You have already written a book. So let's say you're writing a new book. Learn enough math to be a data scientist. Okay. Right. What are the topics that you will include in them?
Right. So actually, we are just working on one such book, and the metadata is in Amazon. It will come out.
Okay, okay.
It's
I
called
didn't
Hands-on Mathematics.
I didn't
Yeah,
know that.
yeah. Actually, I think if you search on Amazon by my name, two books shows up now. One is the published book, another one will be published in February or March 2020, and
Okay,
then I think metadata is always already in.
okay,
So that metadata has descriptions of the topics there. So I can send you the link later, and you can
sure,
actually put them in.
sure.
So I would say very for the sake of brevity here that you start with the very basics. Do not I mean, in machine learning or data science field, three things that people talk about. You always think about the end goal, that you want to do a predictive modeling or something like that, or standard algorithms, regressions, classifications, clustering, three
Hmm.
things. Let's say in supervised learning, and then backwards. I mean, from there, and that what mathematical basis is needed to understand their limitation, their applicability, etc.
Hmm.
So for then you will always you can link those techniques with three things. Probably it's like one is calculus, some ideas, not very advanced, very simple, and then another is of course linear algebra. So and you have to go all the way up to the matrix factorization
Yes,
along with the matrix properties,
yes,
and then
yes.
statistics, right? Very important for data science. Now, this is a big debate about whether how much you learn
Yeah,
about statistics, because
yes.
if you think about the history of the statistics, then statistics actually came about to explain a small data problem, not big data problem, because the statistics was all about you have very limited samples from where you want to estimate the properties of a big population, right? Because you can never measure the population. Looks like now it's opposite, is not opposite, but we are measuring pretty much all the population. I mean, Amazon has data of everybody in the world, so they have a population data. So they do not need to add. Big data was never a forte of like a field where statistics was important, because it's statistics all about. I mean, if you think about where the distinction between a t-distribution and a normal distribution occurs, it's like 30 data points. 30 data points, that's nothing compared to big data, right? I mean, you are talking about 30 billion data points here, so everything is normal distribution. That kind of thing. Then it's very simple. There is no other distribution needed or no estimation needed, right? But you have to learn as a data scientist, where you will find many scenarios where the data. When we talk about it, we think in terms of consumer data, customer data, of transactional data, financial data, etc. They are plenty. But you may go into some industry which is a chemical industry, or biology experiment or something like that, or manufacturing industry. Every experiment costs huge money to there in those industries. And you may get a great job analyzing that data. You may not get a luxury of having many data there point.
Hmm.
So you have to work with small data also. So you have to prepare for that. So build your statistics foundation very well, and do not ignore some of the mathematical topics which are important in traditional computer science, which, for example, is discrete math, which
Okay.
is graph theory, and also permutation, combination, and
Yes,
computational complexity.
yes.
So when you see, I mean, you can do an experiment. You can generate some synthetic data
Hmm.
and just run a machine learning algorithm, and you plot how many data is needed to reach a particular accuracy at that point, right? So now, if you change the parameter of the algorithm, you plot it, and then you get different kinds of shape of the plots, and then you can relate it back to the computational complexity. Even if you do not know theory, from the plots, you will understand that this plot is going nonlinear or square or exponential. Then oh, there is a class of algorithms which talks about computational complexity, and then, oh, I cannot scale this up, right? I mean, if I use this algorithm, because looks like with the given data, as I'm changing the data, this algorithm is behaving as a bad algorithm, which is but
Computationally.
you can understand that only if you have knowledge of this discrete math. So
Yeah.
there it's very important to experiment and have some mathematical basis of knowledge, even because otherwise, without consulting that kind of mathematical background, if you just go and try to scale that and put that into production, you will fail,
Fail,
because
fail, fail.
now then you have to do all the kind of digging later. But why not be prepared from
At the
that? So
initial
those are
step.
very important topics also.
Yes. Just to quick question on that is that, like, you pointed out three things: linear algebra, calculus, and stats. So
Yes.
just two resources or one resources for each, like, which are free and beginner friendly, that you will suggest. Do you have any list of that.
Resources.
Yes.
Yeah, sure. So I think beginner friendly for linear algebra. Actually, you can find a course in EDX platform, which is
Okay.
from UT Austin, University
Okay.
of Texas Austin. It's called LAAF, like linear algebra AF, something for that. They
Okay.
have two courses now. One is high performance linear algebra, but take the one which is basic. It starts absolutely basic. It just describes why it is called linear, right? What is linear about it? Why matrix is a linear operator?
Okay.
What is nonlinear versus linear kind of thing? Extremely simple. It starts. That professor has contributed towards making some of the great routines of linear algebra solver that you may use in actual programs or algorithms package. So that course is very good. For statistics, there is a course in Coursera from Duke University. It's a 5-course topic.
Okay.
It uses R programming languages, not Python, and that's a good way. If you are if you're learning statistics, learn using a different language than you use in data science, right? It always exposes you to different things, functional programming versus object-oriented programming, also that aspect. So that is a good resource. And I guess for basic maths, there a course in also in Coursera. And I have written an article, of course, essential maths for data scientists.
Yes. Yes.
You can put that link in my
Sure.
thing. I have listed all of this course there.
Okay.
I
Sure.
think that article has a very good citation, and it lists step by step discrete maths, graph theory, fundamentals of maths, and statistics and linear algebra, all the free courses that you can get.
Sure.
So
Just
follow that.
Yeah, sure. I'll definitely put that link into the video description, and like whoever is interested in that can go through it. Just to add one more course that is one of my favorite. In Yeah, so there is one course by Gilbert Strang, MIT, 18065. So that
Yeah.
is one of my favorite course. Like it is in my playlist always. So whenever I'm feeling down, he is very funny and he expresses things in a very lucid way. So it is in my playlist always. So whenever I'm feeling down or something like that, I just go through that particular course. So if someone wants to go through that, they can also follow that. That's
Yeah,
free.
Professor Strang is a great propagator of like his teaching, and he is 85 or 90, close to 90, and
Yeah.
still this year or last year he has come up with a book and course or something like that.
Yes.
I
Yes.
mean, he just contributes to the community like
Yeah.
for a long time, 50 years or more.
Yeah, he's an inspiration for me always. Like I look to him for the inspiration. Okay.
Yeah.
So